Okay, so in this first example we have a beam with a pivot in the middle, a fulcrum in the middle, and two forces, one at either end. One force 600 newtons, one force is an unknown force. So we're going to calculate that unknown force. The first thing I suggest you do is to figure out which way the moments are going to go. So to do that, I'm going to place my pen along the beam like this, and I'm going to hold it at the pivot point, and I'm going to push down in the direction of the forces to figure out which way the beam is going to turn. So push down this one, and the beam turns clockwise. So I'm going to stick a little arrow in there to show that the beam turns clockwise. I'm going to do the same the next one. Pen on there, pushing down on this arrow this time, and the beam turns anti-clockwise. So I'm going to stick an arrow in there showing that's going anti-clockwise. Okay, I'm now going to use moments to calculate my unknown force. Okay, so each of these questions answer starts with the same line. So I've got the sum of my moments is equal to 0, which is the same as saying my moments clockwise are equal to my moments going anti-clockwise. Okay, and remember, a moment is equal to a force times a distance to the pivot. Okay, so clockwise first. Our clockwise force is the 600 Newton force, so 600 times the distance to the pivot, which is the 3 meters, and that's equal to our force anti-clockwise, which is F times the distance to the pivot, 2 meters. Okay, so we can work these out. So that's 1800 is equal to 2F, so therefore F, the unknown force, is equal to 900 newtons, and that's our answer for that question.